Hello everyone, welcome back. In this video, we are going to look at some iOS hacking reports. In InfoSec, it is always said that in order to learn something new, you should always read reports. So that's what we are going to do in today's video. I've found four very amazing reports from HackerOne that are related to iOS pen testing. So let's start. This report is onto the application called as Nextcloud. There was an SSRF on the local storage of an iOS mobile. So let's check out how the user lol1ch3ng found an SSRF onto the local storage of an iOS device. So what did he exactly do? The tester uploaded the text file containing test SSRF message in order to prove SSRF attack. So inside the Nextcloud application, there was an upload functionality wherein a text file that contained the message test SSRF was uploaded. Next, the tester uploaded the common file and then manipulated the content and extension file to HTML format in order to find the application path svg slash onload equals to document.write document.location. The tester accesses that file and found the application path to use for SSRF local file disclosure. So what did the attacker do? The attacker first uploaded a txt file. After uploading the txt file, he uploaded a common file and manipulated the content and the extension of the file to HTML format. He manipulated the contents to something like svg onload document.write document.location. He then accessed the file and found that the application path can be used for SSRF local file disclosure. So the application path was vulnerable to SSRF local file disclosure. The tester uploaded the common file and then manipulated the content and the extension file to HTML format in order to view the local file via SSRF attack. So what did he do? He again uploaded a new test file, and in this particular file, he then manipulated the contents and the extension to the HTML format, just like he did before. But this time, he manipulated the HTML content not to something like document.write. Instead, he used an internal file to be disclosed. He used the file keyword over here, that is file colon slash slash. The scheme was file colon slash slash. And then he went on to a particular endpoint wherein the SSRF poc.txt file was displayed. And once he was able to grab this particular file was displayed inside an HTML format. This can be proved using the screenshots which he has given up. So in the step 1.png, he uploaded a file called as SSRF poc.txt file. In step 2, he uploaded a new file, and in this particular file he changed the file name to path.html, and inside this particular file he uploaded svg contents. Now as you can see, the response is 201 created, which basically means that this particular file has been created over here. And step number 3, what did he do? He used the file parameter in order to find the internal path. So as you can see, this is the file scheme, and this file scheme is leaking where exactly the files are being stored. As you can see, for path.html, the file is being stored over here. So in step 4, what exactly did he do is he created a new file called as ssrfpoc.html, and this time, instead of using document.write, he used a file scheme in order to load a particular file from the internal repository. So he used a file scheme in order to load ssrfpoc.txt, and he used a width and a height of 400. You can see that this is 201 created, and when he opened the file ssrfpoc.html, he was able to view the ssrfpoc.txt file. So as you can see, the contents are test ssrf. These are the contents of ssrfpoc.txt file. So this was how this particular user was able to find an SSRF on the local storage of iOS device. The next report is about bug in iOS application which could lead to unauthorized access. This vulnerability was found in the application IRCC Cloud, and a bounty of $100 was rewarded for it. What was the vulnerability? The vulnerability was very simple. The file under the preference folder within the iOS application stores sensitive information. Which file it is? The file is com.irc cloud.irccloud.plist file. So it's a plist file that is storing some sensitive information. This file is accessible from the phone even when the phone is locked with a passcode, suggesting that the application does not secure the file using the appropriate data protection classes. So we have already looked at what are the different data protection classes. This particular application was not using those data protection classes, and we were allowed, or even if an unauthorized user accesses the particular file, it was allowed to view for them. Once the user accesses the file, he was allowed to capture sensitive information such as session cookies. So let me open this screenshot, and over here you can see that this is the plist file wherein sensitive details are stored. So you can see sensitive details such as APNs, Crashlytics, UUID, session keys. Over here, you can see there's a session key which is being stored over here. So any attacker can take this particular session key. He can replace his session with the new session key, and he can then view the account as the victim user. So this was again an unauthorized access vulnerability which was found in this particular application. The third report is about the application Twitter. Twitter iOS application fails to validate the server certificate and sends OAuth token. So failing to validate server certificate basically means that SSL pinning is not implemented properly on Twitter. So as you can see, there was a bounty of $2,100 which was given to this particular user. Now, this is not because he had found SSL pending bypass or the server certification validation did not happen properly. It was because OAuth token was being sent by Twitter. OAuth token is a sensitive token which directly gives you the access to the victim's session. So what are the steps to reproduce? Start burp or any other proxy software in transparent mode. Setting generate CA signed per host certificate, which means that CA certification of burp is used, which is not trusted on the iPhones. You have to then start ROG Wi-Fi access point on the same machine as burp. You have to redirect all the incoming HTTPS traffic on the ROG Wi-Fi access point to the transparent proxy. So over here we are using two proxies. We are transferring all the HTTPS traffic from the mobile device to the ROG Wi-Fi access point, and from the ROG Wi-Fi access point to the burp suit proxy. So there is basically two hops which is happening before the request has been intercepted by burp suit. So this was simply done onto Linux by using this particular command, that is iptables -tnat -a routing, and basically the user routed all the HTTPS traffic onto the ROG Wi-Fi access point and then to the burp suit proxy. Connect the iOS device with the Wi-Fi access point. Open Twitter app on iOS. In Burp, only the calls to api.twitter.com are visible and include sensitive information or sensitive authentication information. So as you can see, the user has given the entire request details. You can see the host is api.twitter.com. The session token has been blurred over here, obviously for obvious reasons, and then you have certain headers which are being sent to the request. Now this particular request is intercepted in Bobsuit, and this is the response to that particular request. Now this request also contained the sensitive OAuth token which was being sent, and hence the severity for this vulnerability has raised to high, that is 8.1, and hence this amount of bounty was given to this particular user. The next report is about blind stored accesses on iOS app due to unsanitized web view. As you can see, the bounty for this is also $100 which has been given to this particular user. This was again reported on Nextcloud. Hi team, I have found a blind accesses that can be executed on iOS app due to unsanitized web view. Using this issue, attacker can extract information from the victim. So what did this particular researcher did was he uploaded a malicious HTML that can be shared to the victim. And what did he do inside that malicious HTML file was he made a reverse connection. Now he was waiting for the victim to open this particular file, and once the victim opened the particular file, as you can see, it got connected to his IP address. Now once he got connected to his IP address, he could have executed any JavaScript related code, and this is a stored XSS. So this is the HTML payload which it has attached, And the recommendation for this is to disable JavaScript on web view. So once JavaScript is disabled on the web view, JavaScript related attacks such as cross-site scripting is not going to happen. So this is the POC which he has attached. The impact for this is that the attacker can extract information from victim, and which information particularly, such as IP addresses, location, the operating system used by the victim, etc. So that's it for this particular video. I hope you understood all the four reports. Thank you.